Welcome, everyone. I am super thrilled to have you here for this explainer, brought to you by Forge College. Today, we are taking a really fascinating leap. You see, if you're coming from an Ethereum background, you probably have a very specific mental model of how blockchain networks operate, right? But as we transition from EVM over to SVM, the Solana virtual machine, well, that mental model needs a bit of an upgrade. Our goal today is to map those familiar EVM concepts directly to Solana's highly specialized, strictly compartmentalized architecture. It's a completely different beast, and honestly, understanding it is the absolute key to building lightning-fast applications. Think back to our previous lesson on validator client diversity for a second. We learned that differences in validator clients can literally change your operational guarantees and performance. Well, that naturally brings up a massive, highly practical question. When you send a request into the Solana network, who are you actually talking to? I mean, who is on the other end of the line? Knowing exactly which employee of the network is receiving your data is your crucial next step. Because if you don't know who you're talking to, you can't possibly know what kind of service or response you're going to get. Okay, let's dive right into this. Here is the blueprint for our explainer today. We'll start with a Solana org chart, define the 3 key node roles, and then follow a transaction's lifecycle. After that, we'll do some real detective work with fingerprinting nodes, and finally, we'll weigh app metrics versus telemetry. Section 1, the Solana org chart, a compartmentalized factory. Okay, so if you're used to traditional EVM nodes, you're probably used to what I like to call a mom-and-pop shop model. That's where a single node essentially wears all the hats, right? It answers user queries, it holds the state, gossips, and participates in consensus. But Solana is definitely not a mom-and-pop shop. It's more like a massive, strictly compartmentalized factory floor. As the documentation officially states, Solana nodes split responsibilities. Some present client-facing APIs, while others participate directly in consensus. This separation of duties, basically keeping the heavy, complex math completely isolated from those chaotic client queries, is the absolute secret sauce to Solana's blistering speeds. Section 2, 3 key node roles. It's time to meet the staff. Understanding the unique personality and, well, the job description of each role will completely change how you design your client architecture. So first up, we have the RPC node. I want you to think of this node as the front desk receptionist. The RPC node is your friendly, client-facing gateway. It handles the JSON-RPC APIs, manages the caching, performs request multiplexing, and enforces rate limiting. It's essentially there to shield the hardworking back-end factory workers from annoying, repetitive client queries. So when your application asks something like, hey, did my transaction go through, or what's my balance, it is talking directly to this receptionist. The RPC node is entirely optimized for giving you super low latency read responses and just an overall smooth developer experience. Next up, we have the leader. You can kind of think of the leader as the shift manager. This is a hyper-scheduled middle manager. Now, a leader is a block producer, but they're only in charge for a very specific, tiny window of time, which we call a slot. During their incredibly brief shift, their one and only job is to collect transactions that are floating around the network, assemble them into a block, and immediately broadcast that block out. They do not care about answering your API queries at all. They only care about packing that block and pushing it down the assembly line before their strict shift ends. And finally, we have the validator. So if the RPC node is the receptionist and the leader is the shift manager, the validator is the back office auditor. The validator is this really diligent, heads-down worker who is participating in the heavy lifting of the consensus protocol. They receive the blocks produced by the leader, independently verify the transactions, vote on them, and then replicate the ledger state. They are completely 100% removed from front-end customer service. Their sole purpose in life is ensuring absolute state finality and consensus correctness. Section 3, the transaction lifecycle. Following the package. Now let's actually see this stuff in action. When you hit send on your wallet or in your app, how does your transaction navigate this whole factory floor? Well, step 1, your client submits the signed transaction package to the RPC node, our friendly receptionist. Step 2, the RPC node does some basic validation, makes sure the package looks right, and tosses it onto the factory conveyor belt, which is the gossip layer. Step 3, the leader, our shift manager, grabs your package off the conveyor belt during their scheduled slot and carefully packs it into a block. And finally, step 4, that block is sent to the validators, the auditors, who carefully verify it, vote on it, and etch it into the permanent ledger. It's just a perfectly streamlined, beautifully compartmentalized process. Section 4, fingerprinting nodes. Welcome to the interrogation room. So here's the thing. Sometimes you point your client at a URL and you don't actually know which type of node is on the other side. Here is your detective's cheat sheet to figure it out without even sending any transactions. You can write a super simple node fetch script in TypeScript to hit 3 specific JSON-RPC methods. First up, get version. If it's an RPC node, you might get a custom server string back just because it's running gateway middleware. But a consensus node, it'll just spit back the standard Solana binary version. Next, we have get health. A dedicated RPC gateway will almost instantly return a really fast OK. But if you hit a consensus node that's currently sweating over block verification, it might throw an error or be incredibly slow. Finally, get epoch info. An RPC gateway should be perfectly up to date, but a consensus node under heavy load might show an inconsistent or lagging slot. By combining these 3 clues together, you create a really lightweight fingerprint to identify the node perfectly. Section 5. App metrics versus telemetry. What do you actually care about? Knowing exactly why you're interrogating these nodes is absolutely crucial, and it really comes down to whether you're a front-end developer or a back-end DevOps engineer. Let's compare them side by side. Application metrics are all about the user experience. You care about API response latency, user-facing finality, and just getting a friendly confirmation status that you can actually show on a UI. Operational telemetry, on the other hand, is the gritty, behind-the-scenes reality. You care about gossip connectivity, CPU load, disk I/O, and tracking those precise slot leader schedules. The receptionist, the RPC node, serves up your application metrics perfectly, but if you want that raw operational telemetry, you're going to need to bypass the front desk entirely and probe the consensus nodes directly. To summarize all of this into a golden rule of thumb, especially if you're transitioning from the EVM world, match the node type to your client expectations. If you need stable APIs and low latency for your users, you query the RPC nodes. If you're trying to understand when exactly a transaction might be included, you need to look at the leaders. And if you need the absolute hard operational truth about end-to-end consensus and finality, you probe the validators. You wouldn't ask the receptionist to do an audit, and you wouldn't ask the auditor to greet your customers, right? Same logic applies here. Before we wrap up, I want to leave you with a bit of a provocative thought to chew on. Imagine this scenario. If an RPC gateway tells you a transaction is confirmed, but you probe a validator and see its epoch info is actually lagging behind, which one do you actually trust? That tension right there sets up our next lesson perfectly, where we'll dive deep into the specific trade-offs between RPC and consensus nodes. Thank you so much for joining me for this explainer. To dive deeper into the subject and explore a wealth of other Web3-related topics, make sure you visit the website forge.college. Keep exploring, keep building, and I'll see you in the next one.